Bismillahirrahmanirrahim. Dear students, I am Ahmed Mumtaz Mustasin, your teacher for CSC 322 Operating Systems Concepts. This is my fourth lecture. In the last lecture, we talked about the hardware reviews, and we talked about the introductory topics, and we ended up at the introduction to different subsystem and modules of the operating system. And we talked about that why we are supposed to have the complete understanding or a little bit understanding of the complete modules of the operating system before we go into the minute detail of each subsystem of the operating system. Okay, so we start from that particular point. The first fundamental concept of the operating system is the processes. What is a process? It is nothing but basically a program in execution. Whatever a program is executed or is being executed at one particular instance, so उस particular instance का, उस particular snapshot का जो related है for a particular task, उसको हम कहते हैं process. Basically, a process is fundamentally a container that holds all the information needed to run a program. We already talked about it, that we need certain information, we need certain support, we need certain resources to run a program. So whatever the program requires for the execution, that is all confined in one container, and that container is called a process. How we can create a process? We need to create a process, we need to delete a process. For every task that we need to carry out on a process, we need a system call. So basically, it is a system call that creates a process and that kills a process or deletes the process. Next very important concept is the address space of a process. अब ये address space मैंने आपको कहा था I/O devices की भी address space है, memory की भी address space है, process की भी address space है, but कहीं ना कहीं किसी न किसी जगह पर जाके they are all tied up with the memory address space. Similarly, process और memory की जो address space है, that have a very close relationship. Process address space starts from 0 to some maximum limit, to some maximum area that a process can access. This process address space could be the subset of the total memory address space. जितनी आपकी memory physical है, उससे ये कम हो सकती है. It could be at par, वो जितनी भी हो सकती है. Or even it could be beyond that. For example, you might have the address total physical memory that has an address space of, let's say, 1 gigabyte. 1 gigabyte की physical memory है, and you want to execute a program that requires an address space of 2 gigabyte. Yet it is possible to execute a larger address space, larger process address space to run on a memory have a physically less address space. So obviously we need the services. We need the services of the memory manager, and memory manager provides us the additional facility in the form of virtual memory. And with the help of virtual memory, we can execute the process that has more address space than the physical memory. So मैंने आज जैसे आपसे कहा था कि ये जो सारी एड्रेस स्पेसेस हैं, इनका बड़ा क्लोज रिलेशनशिप है विद दी मेमोरी एड्रेस स्पेस. और मेमोरी की भी एड्रेस स्पेस जो है वो दो तरह की हो गई अब, जो मैंने अभी बताया रिसेंटली. एक फिजिकल एड्रेस स्पेस जो कि फिजिकली एग्जिस्ट करती है, और एक वर्चुअल एड्रेस स्पेस. वर्चुअली वो कितना बड़ी मेमोरी हो सकती है और फिजिकली वो कितनी बड़ी मेमोरी हो सकती है. We'll talk about it in detail when we talk about the memory management. लेकिन at this particular stage this is sufficient कि you understand what is the process address space. So the address space of a process contains the instructions which are currently being executed. अब मैं पूरे प्रोग्राम की बात नहीं कर रहा हूँ, वो इंस्ट्रक्शंस जो कि इस वक्त मेमोरी के अंदर फिजिकल मेमोरी में मौजूद हैं, द इंस्ट्रक्शंस विच आर करंटली अंडर एग्जीक्यूशन. इसलिए हमने उसे कहा था प्रोग्राम इन एग्जीक्यूशन. प्रोग्राम इन एग्जीक्यूशन और एक्चुअल प्रोग्राम कुड बी डिफरेंट. Program in execution could be a subset of the program that you want to execute. Okay. Similarly, the data. Obviously, instructions are to be applied onto certain data, so that data should also be in this address space. Set of resources means the registers that are allocated to one particular process at one particular time. That could be your program counter, stack pointer, PSW, whatever. The registers, मैंने थोड़ा सा लास्ट लेक्चर में इंट्रोडक्शन दिया था आपको regarding the general purpose registers and the special registers also. Then a list of open files. A process might have created new files, might have opened some files. So all the files which are currently open and the process is currently dealing with them, so they have certain descriptor, certain file descriptor, certain links which are established by the process. So that also needs to be the part or needs to be kept within the process address space. Set of alarms, process might have set up certain alarms कि after every 20 milliseconds I need to send this message to other processes, or I need to send this particular message to this particular process. So एक alarm भी set कर सकता है. So if it has set certain alarm, then that alarm should also be kept. List of related processes, किसके child process कितने create किए हुए हैं, जिन process के साथ ये communicate कर रहा है वो कौन कौन से है, उनका status क्या है, that should also be the part of the process address space. And any information that could be. We almost covered everything, but yet if there is anything else that should also be considered part of the address space. So, process table. What is a process table? It is a data structure. It is a structure that keeps the information related to that particular process. So you need to have one complete entry, one complete structure per process. And this data structure could be an array or a linked list. So the operating system table called the process table, which could be an array structure or which could be a linked list structure, is maintained to keep the relevant information जो मैंने भी थोड़ी देर पहले हमने डिस्कस किया, registers or all related information, that is to be saved somewhere, और वो जो जगह है, वो जो data structure है, उसको हम कहते हैं process table. It contains at least one entry per process which are in existence, not which are executing. एक वक्त में एक process execute हो रहा है, और अगर मल्टी प्रोसेसर है तो हो सकता है एक से ज़्यादा प्रोसेस एग्जीक्यूट हो रहे हो, बट फिजिकली एक वक्त में एक प्रोसेस एग्जीक्यूट हो रहा है. बट देयर कुड बी hundreds of processes that could be in existence at one particular stage, जिसके अंदर बड़ी तेजी से CPU जो है context switching कर रहा है, change कर रहा है from one to the other processes also. So this process table keeps information about processes other than the contents of its own address space. ये कंफ्यूजिंग सा सेंटेंस आपको लगा होगा, लेकिन इसका मतलब ये नहीं कि इट इज डिफिकल्ट. कंटेंट्स ऑफ द एड्रेस स्पेस जो है, दैट इज द टोटल एड्रेस स्पेस दैट वन पर्टिकुलर टाइम अ प्रोसेस इज बीइंग अलाउड टू मेंटेन इन द मेमोरी. जब आप उस प्रोसेस को स्टॉप करके कोई दूसरे प्रोसेस को यूज करेंगे तो ऑब्वियसली उसमें जो इंफॉर्मेशन है वो तो आपने सेव करनी है, लेकिन कंप्लीट कंटेंट सेव नहीं करने. क्या मतलब इसका? इट्स मीन दैट कि फॉर एग्जांपल द प्रोग्राम इन एग्जीक्यूशन, प्रोग्राम तो आपका ऑलरेडी मेमोरी में मौजूद है. प्रोग्राम काउंटर को पता है कि नेक्स्ट इंस्ट्रक्शन which is the next instruction to be executed. लिहाजा उसको duplicate save करना अक्लमंदी नहीं है. ओके, सो जो रेलिवेंट इंफॉर्मेशन है, जो हमने अभी जिक्र किया, जो हमने डिटेल से डिस्कस किया, जो प्रोसेस टेबल में सेव करते हैं, वो सारी की सारी इंफॉर्मेशन विच इज रिक्वायर्ड टू रीस्टार्ट अ प्रोसेस फ्रॉम वन पॉइंट वेयर इट वाज स्टॉप्ड. और ये जो प्रोसेस को स्टॉप करके दूसरे प्रोसेस को एग्जीक्यूट करना है, इसको हम कहते हैं कॉन्टेक्स्ट स्विचिंग. ऑपरेटिंग सिस्टम स्टॉप वन प्रोसेस, स्टार्ट another process either when its allotted time slot has been elapsed. अगर इसको 10 मिली सेकेंड्स का या 10 नैनो सेकेंड्स का या 10 माइक्रो सेकेंड्स की एक सीपीयू टाइम स्लॉट अलॉट हुई है, एंड इफ इट हैज कंज्यूम्ड इट्स टाइम स्लॉट, देन इट नीड्स टू बी स्टॉप्ड. Or if the process might have initiated a system call. If the process has initiated a system call, once again the process might, obviously the process is not in execution, it's related services in execution, the process is not in execution. So the CPU की allocation is not required. तो ऐसी सूरत में when a process is suspended temporarily, maybe due to IO or maybe due to the lapse of the time quota, it must be stopped. When it is stopped, then you should save all relevant information so that the process should be restarted exactly from the same state where it was when it was stopped. जिस पोजीशन के ऊपर वो प्रोसेस था, प्रिसाइजली उसी पोजीशन से उसने प्रोसेस ने एग्जीक्यूट होना है. लिहाजा वो तमाम इंफॉर्मेशन और उसका जो स्टेट है, वो सारे का सारा यू आर रिक्वायर्ड टू सेव इट समवेयर, और हमने उसकी बात की कि दैट इज सेव्ड इन द प्रोसेस टेबल. तो आपको प्रोसेस, एड्रेस स्पेस, प्रोसेस टेबल, कॉन्टेक्स्ट स्विचिंग, दीज आर द फंडामेंटल कॉन्सेप्ट्स दैट आर रिलेटेड विद द processes. Then inter-process communication. Inter-process communication. One process may communicate with another process, or two or more processes could communicate with each other. So there are different methods, different ways through which the process communicate with each other, and these procedures are already coded, are embedded, and are available within the operating system. So process can communicate with other process. Not necessarily that the other process is executing on the same machine. A process may like to communicate or may like to send message to the other process that might have been executed on some other machine. So process के लिए मैसेज को कम्युनिकेट करने के लिए कोई बाइंडिंग नहीं है कि वो उसी मशीन पे प्रोसेसेस चल रहे हो. खास तौर पे आजकल के जो क्लाइंट सर्वर एनवायरनमेंट है, सर्वर्स की एनवायरनमेंट है, यूजर्स की एनवायरनमेंट है, नेटवर्क की एनवायरनमेंट है, हमारा प्रोसेस जो है that might have been executed, I'm sitting in Pakistan and my process might have been executed on a machine which is unknown to me, which is somewhere in America, which is somewhere in Canada, which is somewhere across the globe. I don't know that. I just wanted to extract certain information. I'll send a message to the web server, to the file server, that I need this information, and this information is extracted and provided by the server to me. For that purpose, the message is exchanged across the world over two processes. So inter-process communication has no limitation. Different method exists. You can send a message, you can send a signal, you can establish a pipe, or quite a few that we will discuss it in detail when we talk about the processes. Process has a user ID, a group ID that uniquely identifies a process. जिस तरह आपने खत लिखना है, आपने ईमेल करनी है, तो you need a unique address of the person whom you wanted to send your message or send your email. So just like that, if the two or more processes need to communicate with each other, they should precisely know the identification, the user ID and the group ID, or there could be some more information that I promise we'll talk about it when we'll study chapter number 2, processes. Okay, a process tree. Processes are organized hierarchically, means in the form of trees. For example, a shell. Shell is like GUI. It's just a command prompt through which you can enter or instruct the computer to carry out certain tasks. So you can create the processes, for example, using the shell command. Fork command you can use date, whatever instruction you provide to the operating system, it's converted into the system call, and then a system call creates the process for you. So, for example, A is a process that reads a command from the terminal and it can create further processes. So, the process creates child processes. For example, in the above example, we have seen that A has created B and A has created C. Then we have seen that B has further created D, E and F. So these are the grandchildren of A. So basically we have seen that a process can create a new process which is called a child process. And parent and child process are organized in the form of a tree. Okay. Next is the file system. Operating system hides the complexity, peculiarities of the disk and other I/O devices and present the programmer a very nice, clean, abstract model of their device. Kitni hi complex device kyun na ho, it presents a very pleasant interface to the end user. As simple as just create a file, read a file, write a file, and it hides all the details itself. And these details are basically the part of the file system. Okay, what type of file system the operating system has provided, and all those handling of the devices should match with that particular file system. So there is a concept which is called directory. Directory as a way of grouping files together. Just like ordinary cases may, you might real life may put certain information into one particular container. Offices के अंदर you might have different folders and you want to keep different information in different folders. So यहाँ पर जो folder है basically computer में it is called a directory that contains multiple files. Directory are also organized in the form of hierarchy, just like the processes we have seen that. So the directory hierarchy can be specified by giving its path name from the top to the directory, and this top directory is called a root directory. And then you need a unique path, unique absolute path that traverses the directory from top to that particular point where you want to go. So the absolute path name consists of the list of directory, list of sequence of directories that must be traversed from the root directory to get to that particular file. Traverse किसे कहते हैं? Access करने को कहते हैं. किसी sequence में किसी चीज को access करना, it is called traverse. So you use slash. In Unix you use forward slash, in DOS you use backslash. So basically the slash is the separator between the two directories and between the directories and the file. So obviously, just like the processes, we need a system call to create a process. We also need a system call to create a file, to delete a file, open and close the files. In order to read the data from the file, you are supposed to open the file. And after doing the job, you are supposed to close the file so that it could be saved automatically. This is the structure, tree structure of the files. So you can see that a root directory. This is the root directory. From the root directory, you can we might have the student, or we might have the faculty. The student could be then the list of the students like Robert, Matty, Rio. These are the students. Or you could have a professors. Each professor has got its own directory. Okay, and here you see that I will come back to this. These are the tables. ये जो आप देख रहे हैं, these are the table. These are the entries. Table entries. I will come back to these table entries. These are the entries of the files that are maintained within the directory. So you can create a folder within a folder. Means you can create a directory within the directory, or you can create files within the folder. You can create files within the directory. So this professor has a folder of courses in which he has kept 2 courses which he might have been teaching. Then it might maintain independent folder, and that independent folder might be the papers for different courses. So want to keep it separately so that it could have a separate protection mechanism. That I'll come back to this later on. And then also would like to maintain the results, the grades of the students. So you students are usually very crazy and try to access the grades of their subjects from the computer of their professors, and try to intervene or try to change those grades, but usually those are very well protected. Then the committees for which the professor could be the member, and then these are the details. So this is a hierarchical structure of the file. So the directory is also organized as a tree. So from the root directory to a one particular file, you are required to provide the complete path. For example, if you want to see it here, so it is faculty, Professor Brown, and courses. We usually start, for example, it has not used the term slash here because there is another concept of the working directory. You can set up the working directory. So you can then use that working directory to access the subdirectories and files. Or if you don't want to use this working directory, then you need to use the absolute path, provide the absolute path. For absolute path, for root we use a slash, but since in this particular example, the faculty could be the working directory, so the faculty slash Professor Brown will travel the traversing from this faculty to this Professor Brown, then it will go to the courses all the way down, and then you are within the directory of courses. And then if you use a command to list the files, so you will find the course of CS101 and CS105. So this is the way through which the files are retrieved. Another concept, which is the correlation, we have seen that the processes are also organized in the form of tree. So there are some similarities and some dissimilarity. Similarity is that the processes and files both have the tree structure. The dissimilarity is that the depth of the file structure is much deeper, whereas the depth of the process tree structure is not deep. So you do not have the child, then further child, then further child. So basically it ends up in 2 to 3 stage, where the file could have a very deep structure. Then the life of the process tree structure is very short, just maybe few minutes, or maybe some time through which all the processes are alive. Whereas the life of this file structure could be years and years, and you want to maintain these historical files onto the hard disk. So otherwise they almost maintain the same, because both follow the tree structure. Another concept in the file system is the mounting of the files, and this concept is provided by the Unix. In fact, there is a difference between the Microsoft and Unix is that in the Microsoft environment, rather in the Windows environment, you can deal with devices by giving them the alphabet code. For example, C colon, D colon, E colon, F colon, and then you know that C, D, E are the partitions of the hard disk, and F colon could be your CD-ROM. And then by selecting this alphabet, you can select the device. And then you can use the path, and from that path you can access anything. But the Unix provides you something very interesting. Unix provides you a file system, and this file system is used not only to access the files on one particular device, but you can make any I/O device as a part of the file system. For example, in this particular slide, if you see that we have a root, then we have A, B, C, and D. So you have a root. From root, you have a directory B, then you have a directory A, then A you have a C, and you have D. So this is the file structure available onto the Unix file system. Now, you want to make this CD-ROM, and Unix allows you to make this CD-ROM, this file structure of CD-ROM, as a part of this file system. So how it does that? It allows you to mount this CD-ROM into the position which is B position, for example. /B, root ke baad the directory B, and you can mount this CD-ROM there. Now, the CD-ROM has been mounted at B. So what does it mean? It means that X and Y, these X and Y directories are now available within the file system of the Unix. And now you can access the file on CD-ROM just like you could access it onto the hard disk by simply stating /B/Y. So you will pick up the file from the CD-ROM, and you say that /A/C, you can pick up the file from the hard disk. So by simply replacing the name and using exactly the same concept and the sequence, you can access the files on the hard disk, and with the same method you can access the file onto the floppy disk. So this is something very interesting, and I will further explain it later on, and I'll show you that how the variety of devices you can mount over there in the file system. So if we have this type of facility available, then we would love to mount these files into the file system. So for that purpose, Unix provides you the special files. Special files are provided in order to make I/O devices look like files. So वो जो हमने बात की थी शुरू में abstractions की, files extractions की, abstractions की जो हमने बात की थी, operating system also has one of the two major responsibility to provide you the machine or show you the machine as an extended machine by hiding the all complexity in it. तो हर तरह की डिवाइस जो है आपके लिए will be just like a file. Then there are two categories. You might have a block files, and you might have a character files. So if you want to access some random access devices like disk, like RAM, you can call them as a block access devices. Or if you want to deal with the printer, the modem cards, or the sound card, then you call it as a character special devices. The difference between the block special devices and the character special devices is that in the block you can access anywhere in the device if the device could permit you, whereas in the character access device you have to follow a sequence. Printer के ऊपर आपको write down करने के लिए एक sequence follow करना है. You need to provide the output in a sequence that needs to be printed onto the paper sequentially. Okay? जबकि disk के ऊपर डेटा को राइट करने के लिए या डेटा को रीड करने के लिए, यू आर नॉट बाउंड टू राइट इट ऑन द डिस्क sequentially. So we use the same call for IO as for files. So the operating system treat them as a file. यानी कि special files जो हैं are basically your IO devices, and you treat IO devices as if you are treating the files. Example, you can use, for example, you can mount slash device. For example, we have a root, or in the root, we suppose this is the root, and here is root, and here is the slash device, DEV, slash device. Okay. So if you mount your line printer here, this is your line printer, and you want to print something on the line printer, what you need to do? You need to do simply slash device slash LP. This slash device slash LP. So you can write it onto the printer, because you have mounted the printer onto the file system, and you have mounted the system onto the file system's location device. Usually file is the location in the Unix files, the device is the location in the Unix file system where you usually mount all the devices. Okay, so something very, very astonishing and very useful, that will give you a very good idea that how this abstraction is provided by the operating system. और जो सारी complexities है कि आप उसी command से आप printer को भी handle करेंगे, उसी command से आप modem को भी handle करेंगे, उसी command से आप hard disk को भी करेंगे, उसी command से आप floppy को भी करेंगे, और आपके लिए सारी की सारी devices जो है they are just like files. Okay. Next is a pipe. Process communicate each other by writing into and reading from a file in Unix. हमने थोड़ी देर पहले बात की थी ना कि there are different ways through which the process can communicate each other. So here is an example, and this example says that the two processes can communicate with each other using a pipe. You can establish a pipe between the two processes, and then both the processes can start communicating with each other. So you can implement a pipe just like a file. Once you have implemented, established a pipe using a system call, or using the procedure, or using the syntax of the command provided, it's automatically the establishment of the pipe. I'll show you later on how you can establish this pipe, which is a very, very easiest and the simplest way for the user. So suppose this pipe has been established. This is the pipe which has been established. Now the process A wants to send some data to process D. It will write the data into the pipe as if it is writing onto an output file. Process A ने जो डेटा B को देना है, simply एक फाइल ओपन करेगा. फाइल कहाँ पे ओपन करेगा? इस पाइप के ऊपर फाइल ओपन करेगा, और will write the data into the pipe. And this process B, if it want to read the data or get the message or get the detail from process A, so the process B can read the data by reading from the file. The process B will start reading from the pipe as if it is reading from the input file. So A and B write into the pipe and read from by establishing a pipe, just like they have simply established the pipe, and that pipe working just like I/O of the files. जिस तरह आपने फाइल में I/O करना है, बिल्कुल वैसे ही पाइप्स के अंदर आपने I/O परफॉर्म करना है, and you are not required to learn anything special for that. I/O protection. प्रोटेक्शन कैसे है? Once again, I would like to take an example from the Unix operating system, because Unix operating system gives you a very simple way of setting up the protection systems. Basically, these directories are allocated to different users, as we have seen in the previous example. Suppose there are certain information that a user want to keep confidential. For example, the bank related information. For example, the annual report, for example, the business plan, and one party wants to keep it separate from the other one. So that is provided, the facility is provided by the Unix operating system. So the Unix operating system basically use a 9-bit code. This 9-bit code gives you a very elementary level, user level of protection. But it's very, although it's elementary, but it's very useful. So this 9-bit code is split up into 3 bits for the owner. Owner means the user जिसका वो data है, personal. 3 bit for the group, whosoever is the member of that particular owner. Yeah, you can have a set of users that you can put them as a group. Once you are part of the group, then you have automatically certain privileges that I will explain you later on. Then the 3 bits for the everyone else, whosoever will come onto your environment, come onto your computer and will log in from his or her personal identification, is basically the everyone or the third party. So these 9 bits are basically read, write, execute, 1 bit each. If it is set, it means that you have allow the user to read, allow the user to write, allow the user to execute. Repeat again. This is for the group and this is for the everyone. So if you have given the rights to perform read, write, execute, read, don't write, execute, don't read, don't write, just execute, what does it mean? It means that the owner is allowed to perform read, write, execute. The group members are allowed to read and execute, do not update, do not change, do not write. Similarly, the word, if the guest comes in, he should be allowed to execute the program but should not be able to read the code or change the code or write into it. So the third party is not allowed to read and write. They can simply use it as just like as an executable. In this example, read, don't write, execute, read, don't write, execute, read, don't write, execute. You have set up a scenario where you have whatever you have provided is for the group and for everyone, but you don't want that accidentally no one should be able to change that, to write that, to modify that. For that purpose, even you have put the restriction for yourself also, कि आप accidentally खुद ही ना उसको change कर दें. So you have not allowed yourself to write, not allowed yourself to the word to write, and not allowed anyone else to write onto it. So इसका क्या मतलब है, आप कभी write ही नहीं कर सकते? No. Later on, if you want to write it, you can just reset this mode by using a simple change mode command, and with the help of change mode command you allow yourself to write. So read, write, execute, or at that time you might don't want anybody else to use that, so you can just simply use it like that. So this is a very simple way through which the Unix has facilitated the end user to set up the protection system into the file system. So user can set up the protection system by simply setting up on and off of these bits. So I've given you few examples of the pipes and few examples of reading and writing. So I would like to use it now to explain it. How does you use these pipes and the commands or creating the file by simply writing a simple command. There are different flavors of the shell available in the Unix environment. So you have SH shell, you have a BASH shell. This is another shell. You have a C shell, you have an S shell. So these are different shells which are available in the Unix environment. And this is a very simple command that says that sort file1 into file2 means locate the file file1 and it will automatically look into your current working directory. Will locate the file1, it will open the file, read from the file, sort the contents of the file and write the output into a new file. The name of the new file it will give as a file2. So it will open an existing file, file1, sort the data of the file1 and then write it back the output into the file2. So आप देखें एक सिंपल सी कमांड के साथ sort / file1 then file2. अगर आप देखें दिस इज द रीडायरेक्शन, ये जो इसके अंदर मौजूद है रीडायरेक्शन, this is the redirection, means to read and this is to write output. This is for input, यहाँ से read करो और this is the output, यहाँ पे write करो. So it invokes the sort program with the input taken from the file1 and output sent to file2. Second command, cat concatenate the contents of file1, file2, file3, give the output to the sort. This is a pipe. अभी मैं explain you कि ये क्या करता है. Give the output to the sort process. Sort process will process the contents of file1, file2, file3. file1 को read करना है, file2 को read करना है, file3 को read करना है. Cat means concatenate, इन तीनों को merge करना है. Merge करने के बाद the output place करनी है pipe में. This output will be read by the sort process. This is a command. It will read the data from the pipe to sort. So ये इसके जो तीनों फाइल को कंबाइन करके इसको इनपुट मिलेगी. It will sort that. और आउटपुट कहाँ जाएगी? इसको एडवाइस किया है कि आउटपुट should be placed on /device/lp. Output should be printed onto the printer. So it invoked the cat program to concatenate 3 files. Concatenate कहते हैं combine करने को, 3 files, and send the output to the sort to arrange all the lines in alphabetical order. The output of the sort file is redirected to the file /device/lp. अब अगर आप देखें /device/lp फाइल नहीं है. /device/lp is a printer. So output जो है, instead of writing it onto the file, you will write it onto the printer. Means कि इसको आप printer के ऊपर print कर देंगे. Very simple. Okay. So अगर इसकी जगह पर आप /device या इसकी जगह पे आप कहते हैं /abc/def, तो ये abc डायरेक्टरी के अंदर फाइल dvf के अंदर आपकी आउटपुट सेव हो जाती. बजाय प्रिंटर पे जाने के आप उसको सेव कर सकते थे. अगर आप यहाँ पर let's say d डायरेक्टरी d/e. Okay, so it's very simple. The third command is again the same command, but the difference this command is the last ampersand sign. What does it mean? It's mean that start up the sort as a background job. वही काम जो भी आपने पहले कहा था, do the job, do this job. You instruct the operating system to carry out certain tasks, but do it in the background. Means कि जैसे ही आप इसको submit करेंगे, the control will come back again. The system will give you a prompt quickly to receive the second instructions from you. और ये जो previous instruction है, that will be completed, that will be done in the background. ये background के अंदर ये अपना काम करेगा. So you are not supposed to wait. वो जो cursor blink करता नहीं रहेगा, बल्कि it will just quickly submit it. The job will be done as a separate process. A child process independent भी separate create होगा. One or more processes parallel भी क्रिएट होंगे एंड द जॉब विल बी कंप्लीटेड, बट यू विल नॉट बी रिक्वायर्ड टू वेट टिल द कंप्लीशन ऑफ दैट, और कंट्रोल जो है ये आपके पास आ जाएगा. सो सपोज इफ यू एक्सपेक्ट दैट इट इज अ 10,000 पेज 10,000 line printout that might take 2, 3 or 4 minutes time or 10 minutes time, then you can do something else during this particular time. Okay. So user, we have been talking about these system calls, and quite frequent we up till now. So let us see what is basically a system call. System call is nothing but simply a procedure, a routine, a program, a set of instructions for which the operating system has defined a standard interface. It's an interface between the user program and operating system. So the operating system has defined a precise definition, precise declaration कि किस किस्म का सिंटेक्स होगा और इस सिंटेक्स में पैरामीटर्स कहां पर प्लेस होंगे और डेटा कहां पर आपने प्लेस करना है. क्योंकि मैंने आपको बताया था कि there is a standard which is called a POSIX. This is the POSIX that has ensured कि Unix और Unix से compatible environment में all operating system should follow the same interface. अब बाकी implementation कैसी हो, but for user जो एक टास्क जो है यूजर ने कैरी आउट करना है, दैट इज द सेम वट एवर द प्लेटफॉर्म यूजर इज वर्किंग. ओके, और ये सेम कैसे हो गया? क्योंकि जो सिस्टम कॉल का इंटरफेस था उसको स्टैंडर्डाइज कर दिया. ना अब अपने प्रोग्राम के अंदर वो स्टैंडर्ड इंस्ट्रक्शंस को आप आसानी से यूज कर सकते हैं, और वही सेम इंस्ट्रक्शन विल रिमेन द सेम if you want to use the system call onto another machine, onto another computer. So it varies from operating system to operating system. कैसे? इसकी implementation. लेकिन system call का interface एक है as long as they follow one standard. लिहाजा Unix से compatible जितने भी flavors हैं, they follow POSIX. But it may be different, slightly different, or quite a bit different from the Microsoft environment. So Win32 या Windows environment का जो interface है, that system call का that might be different as compared to the system call, उसके जो corresponding system call का interface है on the Unix. This call is issued by the user program, क्योंकि obviously the user program is supposed to submit a request. The user program submits a request, and this request is passed on to the operating system. So as soon as the user program submits a request, a call uses a library procedure of the same name. क्योंकि जब आपने ट्रैप करना है और ट्रैप करके आपने ऑपरेटिंग सिस्टम में जाना है, तो उसके लिए आपके पास प्रिविलेज नहीं है. उसके लिए एक तरीकाकार क्या है कि आप एक सिस्टम कॉल, एक लाइब्रेरी प्रोसीजर यूज करेंगे. लाइब्रेरी प्रोसीजर इज मोर एजुकेटेड एंड रन्स अंडर मोर स्क्रूटनाइजेशन एनवायरनमेंट, और दैट traps your mode from the user address space to the kernel address space, from the user mode to the kernel mode. तो आपकी इंस्ट्रक्शन पहले जाएगी लाइब्रेरी प्रोसीजर्स के अंदर, फ्रॉम लाइब्रेरी प्रोसीजर इट विल गो टू द kernel mode. So library routine puts the machine into the kernel mode by issuing these special instructions, finds actual routine for system call in a table. Once the control is transferred into the kernel mode, वहां पर आपके पास एक special infrastructure है, special table है जिसका मैंने जिक्र किया था, that contains the address of each and every service. अब आपने सिर्फ उस स्लॉट में जाना है, प्रिसाइज स्लॉट में जाना है, और उस प्रिसाइज स्लॉट में कौन लेके जाएगा? आपको लाइब्रेरी प्रोसीजर लेकर जाएगा. वंस यू आर इन द प्रिसाइज स्लॉट, देन इट डज द वर्क इन्वॉल्व्ड इन दैट कॉल. फिर वहां से वो प्रोसीजर एक्टिवेट होगा, सर्विस प्रोवाइड की जाएगी. वंस दिस सर्विस इज कंप्लीटेड, देन द कंट्रोल इज रिटर्न बैक टू द यूजर प्रोग्राम. Let's take an example of the read system call in the Unix environment. यूनिक्स एनवायरनमेंट में आप रीड करना चाहते हैं किसी फाइल से। अब ये फाइल मैंने आपको बताया कुछ भी हो सकती है, ये आपकी डिस्क भी हो सकती है और इट कुड बी एनीथिंग, वी डोंट नो दैट, but simply we want to read it and we want to read from a file. Okay, so the command is count is equal to read fd buffer and bytes. Fd is a file descriptor. Basically, before reading something from the file, a convention here, you are supposed to open a file. Once you open a file, the open system call returns a descriptor, returns an address, and then subsequently you use that address to communicate to that open file. और वो जो address होता है, that you need to provide it into this parameter which is called fd here, file descriptor. Then you need to provide the number of bytes that you want to read in this read instruction. इस particular instruction में आप कितनी bytes read करना चाहते हैं, वो आपने number of bytes यहाँ पे provide करनी है कि कितनी bytes read करनी है. Then the address of the buffer. Buffer का address जो है वो आपने provide करना है कि ये जो bytes read करेंगे इसको रखना कहाँ पर है. It is the address of the memory where you want to save it so that you can use it. So this fd and the number of bytes is calling by value, जिसमें के आप जो मैंने आपको सी लैंग्वेज में अगर आपने पढ़ा होगा, हमने इसको डिस्कस किया था, कॉल बाय वैल्यू का मतलब है कि विल प्रोवाइड द absolute value corresponding to the file descriptor and absolute number of bytes that we want to read. But here it is called by reference, means we provide the address of the buffer, address of the block where the bytes are to be read. Then something interesting here, count. After completing this read system call, it returns back a count, the number of bytes it has read. Usually it is the same as the number of bytes. आपने कहा था 100 bytes read करें तो ये count की value 100 होगी, लेकिन sometime it could be less than that. कैसे? अगर end of file है और आप 100 bytes करके read करते जा रहे हैं और last में 100 के बजाय आपकी 80 फाइल के बाद 80 bytes के बाद end of file encounter, तो वो 80 bytes return करेगा और count will contain 80 bytes. और if this read fails, आप ऐसी फाइल से रीड करना चाहते हैं जिसको आपने ओपन ही नहीं किया था या फाइल डिस्क्रिप्टर इज नॉट करेक्ट, somehow ये रीड इज अनसक्सेसफुल, इन दैट केस दिस काउंट कुड बी -1 here. This -1 tells the user कि आपका जो रीड प्रोसेस था वो फेल हो गया है. Okay, so let us see it in the diagram, block diagram. This is the user address space. Okay, this is the user address space, and this is the kernel address space where you have the part of the operating system that provide you the service over there. Usually the library is within this user address space that is also loaded. So once you are here, you have given the instruction read system call. तो that read system call में आपने number of bytes provide किए, आपने buffer का address provide किया, आपने file descriptor provide किया, आपने read instruction provide की. So this particular read instruction will take you into the library procedure. So basically you have invoked the library procedure. This library procedure precisely know that where is the routine that will serve you reading the data from that particular file. So it will trap into the kernel mode, take the control into the kernel mode here, and also dispatch the information. This information will take you into the table. This table will pick up the read system call from here. This read system call will be executed. The data will be provided and the control goes back to this library function from where it was called. क्योंकि control वहीं जाएगा जहाँ से request आई थी. After that, it will take the sends the control back to the user program. Control comes back to the user program. Now the user responsibility or user will go to the next instruction. So automatically this whatever information that was saved, क्योंकि जब इसने ये trap हुआ था, जब इस instruction issue की थी, तो next instruction का address was saved onto the stack pointer. So the control has come back to the user program, and now the user should be able to execute precisely from that position from where it has issued the read instruction. रीड इंस्ट्रक्शन के बाद वो थोड़ी देर के लिए ब्लॉक हो गया था, सिस्टम ने सारा प्रोसेस कंप्लीट किया, प्रोसेस कंप्लीट करने के बाद सिस्टम ने कंट्रोल वापस दिया, जब कंट्रोल वापस आया तो प्रिसाइजली उस लोकेशन पे जहां से ब्लॉक हुआ था ये एग्जीक्यूट हुआ. सो आई होप यू शुड बी एबल टू डिकोड इट, जो मैंने सारा आपको एक्सप्लेन किया. एक चीज यहाँ पे आपको नजर आ रही होगी विच इज अ डिफरेंट, दिस इज द एड्रेस स्पेस. This address space contains 1, 2, 3, 4, 5, 6, 7, 8F. So 1F is basically 1, 2, 3, 4. 2 raised to the power 4 minus 1 means 15. So this is basically the 4 bits. So here we have got 8. 8 का मतलब हुआ 8 into 4, 32 bits. So basically this address space is 2 raised to the power 32. So 2 raised to the power 32 means this is a 32-bit address space. ये जब हम जाएंगे मेमोरी वाला पोर्शन पढ़ेंगे तो वहाँ मैं ये आपको सारी कैलकुलेशन करना सिखाऊंगा इंशाल्लाह. Okay? So let's move forward. Now there are different categories, different system calls. There is a system call, हमने एक example ली है 5 read write system calls की. Okay? So I'll just quickly go through it. There are a process management system call. For example, PID is equal to fork that basically, where is my cursor gone? It is here. This is. It creates a child process identical to the parent process. Fork command, Windows में भी fork use होता है to create a process, और Unix में भी we use a fork. Then next is wait. PID, it wait for the child process to terminate. So means you might have assigned certain tasks. When you assign a certain task, a child process has been created. It waits till the task has been completed. Once the task is completed, then the child process is killed and control comes back to the calling program over there. So basically you put the parent process into the wait mode over there. Executive, replace the process core image. Basically, you want a certain execution program. So you, for example, you have submitted certain command to execute. जो हमने भी आपको example भी दी थी, cat command for example, concatenate 3 files and put the result back. तो उस basically आप वो सारी की सारी command जो है in the form of a system कॉल में ऑपरेटिंग सिस्टम उसको ट्रांसलेट करता है आपकी कमांड को, और उसके लिए यूज करता है ये सिस्टम कॉल executive. EXECVE is the executive means executive, and it loads the arguments, loads the environment and provides the parameter, and then it image of that particular is loaded into the routine which is available, comes into the user address space, process address space में वो image load हो जाता है for the execution, and next is the exit status. So ये कुछ examples थी for the process management. File management, file management में हमने example already देखी, this where is that, read. This example we have already talked about in detail. मैंने आपसे कहा था किसी फाइल को रीड या राइट करने से पहले उसे ओपन करना पड़ता है, और you open a file. Once you open a file and you open up into certain modes, the system returns back an address, and this address is the field descriptor, और ये वही field descriptor है जिसको हमने यहाँ पर यूज किया था. Once we have completed with the file, read and write process has been completed, हम यहाँ पे simple close system call use करते हैं, और यहाँ पे भी हम यही वाला file descriptor use करते हैं कि the file having this file descriptor should be closed. ये read के भी है, similarly the same is for the write, and then else we'll talk about it, and I think you might have studied that in the प्रीवियस कोर्स हमने सी प्रोग्रामिंग में एल सीख था, डेट मूव अ पॉइंटर टू द स्पेसिफिक लोकेशन ऑफ द फाइल. Then there is stats, name and buffer, gets file status information. This is also a system call. File mode. When you open up a certain file, it is open up in certain modes, and all related informations are required to be kept and tracked. And this could be whether it's a regular file or whether it's a special file, what is the date of creation, what is the date of modification, who is the owner, what is the current size, and what are the access status, कौन कौन सा read, write, execute वाला, what are the access status of the file which that user could be able to retrieve with the help of stat commands. So these are all available facilities और ये system maintain करता है file mode के साथ. Next few more system calls for the file management, directory and file management. हम directory को भी file की तरह treat करते हैं. So for that purpose we have got few systems calls. For example, make directory means create a directory. और मैंने आपसे कहा कि directory is just like a file, but it has certain obviously features attached to that. Okay, it may contain the folder that आगे further contains the folder that may further contains the file. So it's a hierarchical structure. So you want to remove a directory, you can use rm directory command, create a new entry, name 2 pointing to name 1. This is something very interesting. I would like to discuss this link maybe today at the end of the lecture or maybe in the next lecture. So याद रखिएगा, I'll give you with an example. This is something very good available in the Unix. Unix आपको provide करता है link और unlink करने की facility where you can link a same file for multiple users. और एक से ज़्यादा यूज़र हैं, एक को वो फाइल नज़र आती है किसी और नाम से, दूसरे यूज़र को नज़र आ सकती है किसी और नाम से, और दोनों वो शेयर करते हैं फाइल को, और if someone makes certain changes it's automatically made available to the other person because precisely the file remains the same, the link is provided to the other user. So एक के लिए फाइल का नाम है और दूसरे के लिए लिंक है, तो basically two names for one single file. माउंट हमने ऑलरेडी बात की, माउंट की, हम किसी भी फाइल सिस्टम को माउंट कर सकते हैं यूनिक्स फाइल सिस्टम के साथ, और अगर माउंट कर सकते हैं तो उसको अनमाउंट भी कर सकते हैं. ओके, ओह वेरी नेक्स्ट स्लाइड. दिस वाज जो मैं अभी आपसे प्रॉमिस कर रहा था, लिंकिंग. A Unix, each file is identified by the I number. I number जो है, these are the I numbers. 16, 18, 40. This is an index basically. That index takes you to that physical location of that particular file. Ab we can simply use this particular link. We can first create the link and then we can use the link. So link creates a new directory entry with same inode number. देखिए, /user/ast/user/jim, jim. In this particular example, you have जिम के पास एक फाइल थी जिसका नाम था मेमो, जिसका आई नोड था 70. सेम इंडेक्स जो है, जिम ने क्या किया कि इसको लिंक कर दिया फॉर AST. उसी सेम आई नोड के साथ it has given it a name node, so has a new name node instead of memo. फाइल मेमो जो है is for जिम, लेकिन for AST it is a node. Same file है because both have the same inode number. So this file is made available to both of the user, Jim and AST. Both user can access that, both user can modify that, both user can use that because it is being shared between the two users by duplicating the link into the file but with the different name. So this is some feature which is not in this form, simplest form available in some other platforms and some other operating system. Okay. माउंट सिस्टम कॉल, इसका एक और फ्लेवर हम डिस्कस करना चाहते हैं. माउंट /device/fd0. FD0 फॉर एग्जांपल आपकी फ्लॉपी डिवाइस है जिसको कि आपने यूनिक्स एनवायरनमेंट में स्लैश डिवाइस के ऊपर माउंट किया। अगर आपने इसको माउंट किया हुआ है एंड नाउ यू वांट टू मूव इट टू /MNT, आप इसको एक सेपरेट पोजीशन के ऊपर दिखाना चाहते हैं तो यू कैन जस्ट इसको मॉडिफाई कर सकते हैं ऑन टू दी, इट वॉज फॉर एग्जाम्पल एन इंडिपेंडेंट, इस स्टेज पे हम कह सकते हैं इंडिपेंडेंट है और इसको आपने मूव किया एक और लोकेशन के ऊपर। सो दिस इज अ सिस्टम कॉल दैट use this one input, this is the output, and this is the third parameter that tells the operating system कि इसका फाइल का जो है वो मोड क्या है, it's a read or write. So basically it is some code 0, 1, 2, 3 that basically decoded as it's allowed read or it's a read write or read write execute. So this is the third parameter. So file comes from the drive 0 and is now mounted on binary file /MNT. Result is that the file on drive 0 can be accessed from a directory. Okay? पहले वो डिवाइस थी और अब वो डायरेक्टरी इसके ऊपर माउंट होने के बाद इस डायरेक्टरी के साथ एक्सेस हो सकती है। So we have seen the example previously for the CD-ROM और मैंने आपसे प्रॉमिस किया था कि I will give you one more example where we will use that. There are some other system calls, for example change directory, change mode. ये वो जो change mode है ना जो मैंने आपको बताया था कि आप मोड सेट कर सकते हैं, ये वो उसकी सिस्टम कॉल है। Kill, PID and signal, you can send a signal to a process, for example, to perform, to delete the process or do something else if you want. Seconds is equal to time, address in seconds. If you want to find out the total time since 1st January 1970 in terms of seconds. Seconds में क्यों करते कि फिर आप सेकंड से आसानी से उसको कन्वर्ट कर सकते हैं in terms of hours, days, months, years. So आप उसको convert कर सकते हैं. Basically this is something that which is kept and maintained by the system and its time is provided to the end user for number of purposes that the user might be interested in. Windows Win32 API. Now we have talked about the system calls available in the Unix environment. Almost the similar or slightly different system calls are also available in Win32 environment. अगर हम क्विक भी देखें, fork command हम already देख चुके हैं, to create a process Unix में भी है, wait PID Unix में भी है, exe, cve, execute, create a process, फोक भी करता है प्लस एग्जीक्यूटेबल, जैसे कि आपने शेल के अंदर फॉर एग्जांपल टाइप की थी कमांड सॉर्ट की, तो ये सॉर्ट का प्रोसेस भी क्रिएट करेगा और उसका एग्जीक्यूटर भी उसके अंदर लोड करेगा, क्योंकि हमने सॉर्ट का प्रोग्राम नहीं प्रोवाइड किया था, इट वाज इन द फॉर्म ऑफ ए कमांड, तो उस कमांड का जो कोड है वो उस प्रोसेस में लोड भी करेगा। एग्जिट दोनों में मौजूद है, ओपन वी हैव सीन दैट, रीड एंड राइट वी हैव सीन दैट, lseek we have seen that, stat we have seen that, make directory, remove directory is there, link is there. Win32 does not support wing, so this is not there. Similarly this command is not there, sorry, this is fork. Okay, ये काम हम करते हैं कैसे, fork और exevc से number of commands को combine करके, both commands combine करके, okay. So mount is not there in Windows environment, so unmount भी नहीं है, फिर इसलिए change mode उसमें किसी और तरीके से किया जाता है कि उसमें there is some other way. So these are some matching and some mismatching system services or system calls available for the Windows environment. So let me see what do we have next. Okay. Next is operating system structures. We have gone through some basic concepts और इन concepts की मदद से अब हम इनको one by one detailed study करेंगे जब हम subsequent लेक्चर्स को स्टडी करेंगे. There is another concept that gives you a good understanding of the structure of the operating system. There are different models of the operating system which are available and which are followed by the new inventors, or they can have a hybrid approach by combining the concepts given in different good practiced operating system structures available. These are monolithic system, RAID system, microkernel, client server model, virtual machine model, and exokernel. Inshallah, we will discuss all these one by one in detail in the next lecture. So I hope that you have enjoyed today's lecture. I've tried my best to be very brief and detailed simultaneously. जो information जितनी pass on करनी थी, कहीं मैंने details explain की, कहीं मैंने उसको briefly explain किया, because I don't want to confuse you at this time. So let us see that whatever we have learned today is useful in our subsequent lectures, when we will be talking about all the modules of the operating system in detail. Okay? इंशाल्लाह अगले लेक्चर में फिर मुलाकात होगी. टिल देन अल्लाह निगहबान. खुदा हाफिज़.